Hello everyone, welcome back again to PLaxis 3D Shallow Foundation course from theory to practice. This is lesson 50 and in this tutorial we're going to simulate a shallow foundation on soft clay and reinforce it with the stone columns using PLaxis 3D. So before we start simulation using PLaxis 3D, I will shortly talk about stone columns and its application in geotechnical engineering. Generally, stone columns are one of the methods used to improve the load-bearing capacity of shallow foundations on soft clay layers. So when we have soft clay layers and we want to build a structure which has a foundation, so it may be a lot of settlement problem. So this kind of technique are used to improve the bearing capacity and settlement of the soft clay. Also, this technique or this method involves using a vibrofloat, which is water jetted into a soft clay to create a circular hole extending to a more stable soil below. So as you can see, this is a vibrofloat machine and used to create a hole inside the soft clay or soft soil layer until it reaches a well soil or stable or more strong soil layer. And after that, this kind of granular material, generally crushed stone or gravel, are poured into this hole and compacted. And this imported gravel in practice generally ranging in size from 6 millimeters to 4 millimeters, and also the diameter of the stone columns are generally between 0.5 to 0.8 meters, and the center to center distance between these columns generally ranges between 1.5 to 3 meters. Application of this soil improvement technique in geotechnical engineering involves, as we said before, supporting foundation. So stone columns are installed under a shallow foundation to increase bearing capacity and also reduce settlement in soft or loose soil. So it may be a soft clays or sills. And this kind of improvement effectively improve soil stiffness and stability. Also can be used to reinforce the embankment and stabilize slopes by improving shear strength and reducing a lateral displacement of the soil. Also in soil layers or in soils when a liquefaction is susceptible, especially in earthquake regions, and these techniques are used for densifying a loose granular soil, so improving their ability to withstand a cyclic loading during a seismic events. And the examples which we are going to simulate using PLaxis are shown in this figure. The foundation is 7.8 meters by 7.8. We have a number of stone columns. The diameter of stone columns is 0.8 meter, which is 80 centimeters. Also, the center to center or the spacing between center to center of the stone columns are 2 meters. So we have two soil layers. One of them is a soft clay, which is 7 meters. Also below this soft clay we have a strong sandy soil layer, which is 30 meters, and below these layers we suppose there is a very hard or a rock soil layer. So we will apply a surface load to the foundation. Also, the length of the stone columns are 8 meters. So generally we have to penetrate at least 1 meter of a stone column into a stable story layer, as you can see in this example. So to reduce a calculation time in PLaxis 3D, we will only model 1/4 of the model. So we will just model 1/4 of this matte foundation and 4 stone columns, as you can see in here. So we will just model like this one in PLaxis 3D. And start the calculation right now. So we click on calculate. Okay friends, after a long time the calculation is done, so we can start viewing the calculation. We save the project and we can click on view calculation results. So we can see in here, this is a deformed shape of the problem. We can see in a case when we have a stone columns reinforced soil, the maximum displacement is about 9 centimeters, and for unreinforced soil we have about 21.5 centimeters. We can see the displacement is reduced by more than 50%. We can see the total displacement contours, as we can see in here. This is for unreinforcement soil, and this is for reinforced soil. We can check the displacement vectors, as you can see in here. Okay, we can also check the displacement in stone columns. So I click on deformation, total displacement, and we can hide this soil volume. For example, I expand this one and click on here, and this one should be unhide. Okay, we can see in here these are the stone columns, and most displacement happens at maybe 2 meters, upper 2 meters of the stone columns. We can check the displacement in X direction. We can see in here in these 2 stone columns, the most displacement in X direction happened in these columns. Also displacement in Y direction we can see happens in here. We can also see the deformed shape of these stone columns, as we can see in here. It's like a backlink in concrete columns, because the soil is soft. The soil around the stone columns are soft and cannot provide lateral support for these columns. We can also check the load displacement curve as well for unreinforced and reinforced soil. So we click on here, curve manager, create new, and in X direction if we select the M stage, in Y direction if we check the displacement, in Z direction. Okay, so let's create 2 separate one. This one for unreinforced, and in this case I will just activate the unreinforced construction phase. Also I can add the load displacement curve for stone column reinforced soil. So I right click on the figure and add curve from the current project and click OK, and also I can edit the name, reinforced with stone columns, and as we can see in here that there is a considerable improvement in displacement of the foundation. It decreases from 21 centimeters to about 9 centimeters. Also it increases the stiffness of the soil. Okay, maybe some we can save in here. Maybe in practice the settlement is decreased more than in this example in PLaxis. This is because in practice when we add, for example, if I show you in here. When we add these stone columns and compact it, also the soils, the soft soils in here is get compacted and densified, and the unit weight is increased. Also the shear strength is increased. So we didn't change anything in these regions in numerical analysis. That's why maybe in practice the settlement is get more improved that in numerical analysis in this example, and we can do it by increasing the unit weight in of the soft clay, also maybe the shear strength properties as well. Okay, this was for this example. I hope it was clear. Thank you for watching, and see you in the next lesson.